Hello class, today we're going to be talking about two properties of triangles. The first property we're going to be talking about is triangle, angle, and side relationships. And here you can see we have three types of triangles. An obtuse triangle, an acute triangle, and a somewhat right triangle. And as you can see that they are all scaling triangles, which means none of the side lengths are the same. But let's take a look at the relationship between the largest angles and the largest side. So here in this obtuse triangle, we can see this is the largest angle. And which side is the largest side? So this side, this side, this side. If you said the side across from the largest angle, you're absolutely correct. Let's see, does that property hold in the other types of triangles? So we go over here in this green triangle, which is the largest angle. We see here the largest angle is F, and right across from it, we see that the largest side of the triangle is 7 units. Okay, so again, the longest side is across from the largest angle. Over here we have a somewhat right triangle. The largest angle is angle H with 90.112 degrees. And we look at all the side lengths of the triangle, and we see that the largest angle is across from the longest side. So we have one relationship that we can see based off different examples, is that the longest side is across from the largest angle. And as we were to change so that the right angle is no longer the angle H is no longer the largest side, and we make another angle, in this case angle I, the largest angle, we can see across from it, across from angle I, which is now the largest angle, is also the longest side. So there is a relationship that we have shown inductively by different examples, that the longest side is across from the largest angle. Does the same hold with relationship to the smallest side? Is the smallest side across from the smallest angle? Well, let's take a look at our examples. As we can see here, in triangle ABC, angle C is the smallest angle, and if we look directly across from it, we can see that the smallest side is across from the smallest angle. Let's see over here if that's the case. Triangle DEF, the smallest angle is angle D. And if we look at the different side lengths, the smallest side is right across from angle D as well. And no matter, as we change our triangle so that now the smallest angle is no longer D, here the smallest angle is E, we can see here that the smallest side is directly across from angle E. And so this is important relationships that we see between these two triangles, between any triangle. So as we can see in our notes that we have these two theorems on page 73 that are from the note-taking guide. And these two theorems say essentially that Theorems 5.10 says if one side of a triangle is longer than another side, then the angle opposite the longer side is what? Then the angle opposite the shorter side. Well, if the angle, of course it would have to be larger, because if the angle is, so as we can see here, AB is larger than BC, or longer than BC. So let's take a look at the angle across from AB, and the angle across from angle AB, from side AB is angle C, and the angle across from side BC is angle A. So that would have to mean that angle C is a larger angle measure than angle A. Let's go down to Theorem 5.11. If one angle of a triangle is larger than another angle of the triangle, so as we can see here, angle A is 50 degrees, angle C is 30 degrees, so that means the measure of angle A is greater than the measure of angle C, then the side opposite the larger angle, which in this case is BC, is going to be what compared to the side opposite the smaller angle, which in this case is AB? Well, if you said that BC is going to be larger than AB, you're absolutely correct, because it's going to be longer, because AB is across from the smallest side. It's across from the smallest angle. So now we're going to take a look at a very important theorem in geometry called the triangle inequality theorem. But before we take a look at the triangles, let's just start off with the line segment AB. And let's say that the AB is exactly 10 units long. 10 centimeters, 10 units, it doesn't matter. And I'm trying to figure out what can I make the other sides of the other line segments so that I can form a triangle. How long do those line segments need to be? So let's take a look here. Let's take a look up here. We have a slider S1. And I'm making it really long, trying to get to the other side. Well, right now, with these three side lengths, the 10, the 3.75, and the 1, will I be able to make a triangle? And if you said no, you're absolutely correct. So the question is, at what length do these side lengths need to be, these other side lengths need to be, so that I can make a triangle? Well, let's see. Let me make this very long. Let me make this length almost 10. Do I still have enough length to make this a triangle? Even though now this is a very long side. And if you realize no, you're absolutely correct. So there are certain lengths that no matter how long this one side is, you will not make a triangle. So let's see if we can come up with a relationship between the side lengths that will allow us to make a triangle and the side lengths that will not allow us to make a triangle. So let's try and keep AC, side 1, constant at 9.75 units, and let's try and keep, of course, AB constant at 10 units, and then try and figure out how long does DB need to be so that I can make a triangle. So as I move this up, I see that at this point, oops, it almost looks like I have a triangle where DC has to be connected to this self. So let me move this up. Almost, but no cigar. Let's try moving this up. Almost, but no cigar. So we still have to try some more. So we finally got a triangle with the side lengths of 9.75, 3.25, and 10. Now let's take a look at what the relationship between these side lengths that make a triangle, whereas if I were to move side length 2 to a smaller side like 3, it would not make a triangle. Let's take a look at the triangle inequality theorem. And it says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. And so what that means is no matter how long the other two sides are, they have to be greater than the third side. The sum has to be greater than the third side. So the sum of any two sides has to be greater than the length of the third side. So let's see if that's the case with our triangle that didn't quite make it to become a triangle. So here we have, this is our third side. So let's take it side 1 plus side 2. Well, side 1 plus side 2 is going to be 12.75. Is that greater than 10? Yes, it is. So far, the sum of these two sides is greater than the third side. But let's take a look at just looking at side 3 and side 2 and side 3. Well, side 2 is 3, side 3 is 10, so that's 13. Is that bigger than the third side? Well, yes, that is the case. So that holds. Remember, the triangle equality theorem says any two sides. So let's take a look at, in comparison, side 3 and side 1. 10 plus 9.75 is 19.75, and that is greater. So these three sides should make a triangle. So what I'm going to do is I'm going to bring C down, and yes, it does make a triangle. Now let's take a look at an example that no matter how I bring down, it's not going to make a triangle. So let me do it like this. Okay, and here I can see that still makes a triangle. Bring down here. Oh, doesn't quite make a triangle. Doesn't quite make a triangle. So let's take a look over here and see what's going on. Let me make sure that that doesn't hold. Oh, yes it does, right there. As we can see here, that no matter where I move these two side lengths, I cannot make a triangle. Well, let's take a look at their side lengths. Side 1 plus side 2 is going to be 9.75 plus 0.25, which is 10. Is that greater than the third side? No. So that is why we can't make a right triangle, is because the sum of these two sides is not greater than the third side. In fact, it's equal. So in order for three side lengths to make a triangle, the sum of any of the two sides has to be greater than the third side. So AB plus BC has to be greater than AC. In this case, AC plus AB has to be greater than AB, and AB plus AC has to be greater than BC. My trick and my hint is, instead of having to test all three of these, why don't we just test the first two smallest sides and see if they work?